We're standing in a planted stand of Douglas fir right now, and if you look around, you'll notice all of these trees have paint markings on them, and then also they have metal hang tags to identify them. Cheryl, can you talk a little bit about what the purpose of this stand is and why the trees are marked like this?
Yeah, sure. So this is a long-term growth and yield trial. So there are permanent sample plots in here. And the idea with that is that you're going to track individual trees throughout their life for a long period of time. And that's what we mean by permanent sample plots. So these plots are remeasured at regular intervals. And they're 65 years old now. They were planted in the 1950s, and so if you take them right back to their age from seed, they're exactly 65 years old this year.
And so they're measured at periodic intervals to try to figure out growth rate, probably in DBH and probably in height as well.
In height, yeah, absolutely, and a whole host of other attributes to do with growth and yield and stem quality and value. Okay. There are plots in here in Douglas fir, Western hemlock, and Western red cedar, but back in the 1950s when they set this all up, they wanted to figure out how they all grew separately. So these are just Douglas fir that we're standing in here. In other places we have plots of pure hemlock, and there are also plots of pure cedar.
Got it.
Mixing them up is a whole different study altogether.
Yeah.
The interesting thing they did in these ones that we're standing here is they tested the species growing at different densities.
Oh, okay.
So they used a range of 5 different initial densities, from very tightly spaced, very dense, to much more widely spaced,
so
low
it's
density.
to inform management so that
Right.
under similar conditions, figure out what an ideal spacing of the trees
Exactly.
is. And I suppose if you space things too closely, then you potentially impede growth of the trees, whereas if you have things spaced too far, you might have more competition from other species coming in, or just not reach the full yield that you might be able to otherwise.
That's part of it. Over time, it's interesting because the yield curves of these different spacings tend to become more and more similar over time, because you have the really dense plots, the trees are competing against each other, there's going to be competition-induced mortality, and so the numbers of trees is going to decline
So
anyway.
they're self-thinning.
They're self-thinning over time, whereas the ones that are initially quite wide and have difficulty capturing the whole site, they'll grow very fast, and eventually they will fill up the whole site. So all those curves tend to converge towards each other over time. But what's also really interesting is that the growth form of the trees is quite different, just in terms of the growth rate, the ring width, and also the branching. So you know, the ones that are more open grown are going to have much longer, thicker branching, for example, and much bigger, wider crowns, and that's going to have an influence on the wood quality as well.
Okay. And am I correct that this is not a provenance trial? So we do not
Right.
have trees. So we have trees all from the same provenance.
That's right.
And the variable that was being investigated here was different spacing, to
That's
see
right.
how the trees respond.
That's
to that.
right. We have a whole lot of different kinds of permanent sample plots here and different kinds of research trials. So we do have quite a few provenance trials as well, but this is nothing to do with testing different, genetic seed sources. It's all just purely looking at the initial density.
And do you know how long the study is intended to run?
Well, there's a whole range of researchers that are interested in this, and time will only tell how long they decide this is useful for, but it's still very important. So at 65 years, there is nobody in the group that wants to cut these down and replace them with something else. They're still valuable. So I would think if you're going to be doing growth and yield studies, you want to follow the trees for at least a full rotation. But even then, what's a rotation? I mean, at 65 years, certainly the stand could be harvested. We've probably reached the culmination of mean annual increment, but that's only one way of looking at what the potential rotation is. I mean, really, these Douglas firs are very long-lived, and there might be a lot of good reasons to find out how they behave for longer periods of time, for prescriptions where we have longer rotations for other kinds of reasons and other values.